Hi everyone, welcome to yet another episode of Data Dialogues. I'm Julien Redmond, General Manager of Certus Insights and the host for the series. This episode today is a really interesting one by a really good friend of mine, Vincent McBurney. Vincent presented this at the Worldwide Data Vault Consortium back in May 2020, and it's a really good look at the current state of automation tools. We thought it was really worthwhile having this as part of the Buyer's Guide series that we're doing with Data Dialogues and through the Data Vault Innovators community right now. It's a really nice in-depth snapshot of the sort of content that you receive if you attend the Worldwide Data Vault Consortium, but also a great snapshot for those that are thinking about what they need from an automation platform. So we'll dive into that in a second, but first just wanted to have a quick chat about the Data Vault Innovators community. It's a community for all of you out there. It's really about technical professionals, professional development, conversations and debates, sharing of ideas, case studies, technologies, any ideas that relate to Data Vault that help people to be successful. And since we're coming to you through YouTube, we'd really like you to subscribe. And if you enjoy the series, or this episode at least, hit like, hit the notification so that you get updates about the next episode. But for now, let's go have a listen to Vincent.
Hi, welcome to Choosing the Right Data Vault Automation Approach. I'm Vincent McBurney and I work for MLC Insurance in Australia. The agenda for today is to look at the movement of data from landing into raw vault and automation approaches for that. We'll compare some Data Vault automation tools out there on the market. We'll talk about how to get the most out of Business Vault and what kind of tools can help with that. And we'll sum up with the conclusion. I won't go a lot into the principles of Data Vault or Data Vault modeling because I assume most of you already know that. But we're looking at the standard layers of Data Vault, landing into raw vault, into Business Vault, into marts. Typical information architecture for this kind of thing is to have a policy management system, underwriting, claims, finance, and CRM as my main business systems. And I'm pulling that data into a Data Vault on a relational database. I can have a data lake alongside the Data Vault. That's usually in a Hadoop system, so not as efficient at storing relational data. So it tends to store things like files and PDFs and log files. My raw Data Vault storing data in hubs, links, and satellites. And then in my Business Vault, I have my enterprise data. Business Vault's a sparse layer. I don't have to put all of my Data Vault into my Business Vault. I'm focusing on key domains like a single view of cleansed and consolidated policy, product, customer, and some of the key measurements of the insurance industry like exposure, claim cost ratio. I can also use some advanced learning models or prediction models or lapse propensity models in my load that into my Business Vault. Then I have the information mart layer where we can have a customer mart, a product mart, a claims mart, and a data quality mart. And then finally, the dashboards, the management reports that run off each mart. Let's take a look at the Data Vault build process. Typically, in a Data Vault load framework, we're looking at these type of tables that need to be loaded. We have our standard hub tables holding unique lists of business keys. We have our satellite tables, which contain all the descriptive data, all the original records that describe those business objects. And we have the link tables, which contain our relationship data or our foreign keys and join our hubs together. They can represent a relationship or in a parent-child relationship like a hierarchy, or they can represent transactions or payments as a non-historized link. There are also some more advanced types of Data Vault automation that you can put in place, the point-in-time tables and the bridge tables. These are used for query optimization. I don't see them at all the Data Vaults I've worked on, but when they are in place, they do result in much faster queries against the Data Vault and easier query writing, and it makes it easier to populate your data marts. And we also have a couple of other types of satellites, a status tracking satellite and a multi-active satellite that tend to be more advanced types of Data Vault automation. And of course, we have our reference data, which can just be stored as standalone tables or in their own hubs and satellites. Reference data isn't linked into the main data vault because it's just a set of codes and descriptions that gets merged in during the creation of the information marts. So we're going to be looking at data vault automation for all of these types of tables. When we consider data vault automation tools, I put them into 4 brackets of tools. I start with the top tier, which is those tools that have been built to do data vault automation. Examples being Vault Speed or Data Vault Builder. They're designed from scratch to build data vaults. They tend to have the fanciest user interfaces, and they tend to be the easiest ones to use because they're designed to do data vaults simply and easily. And they tend to take you through all the steps of data vault automation from start to end. And they can either directly populate the data vault or generate scripts for you to go and populate the data vault in your database engine. The next category of data vault automation are data warehouse automation tools that have data vault added. Examples of this include Warescape, Irwin, and Varigence. These are tools that have been doing data warehouse automation for many years, and they were aiming at automating things like data marts or automating the process of turning mapping specs into data marts. They tend to have code generators in them, and they started out as data warehouse automation, and they jumped on the data vault bandwagon, and they've been customized to support data vault patterns through special configurations of these tools. The next category is using a data integration suite and building your own data vault automation into that suite. Examples here include Informatica, IBM Information Server, SAP Data Services, or Talend. There's a couple of approaches to getting these integration suites to do data vault automation. The first is to simply have template jobs. So to build a sample job for a hub, a link, a satellite, a multi-active satellite, and turn that into a template that other developers can use to populate their own hubs, links, and satellites, so that every single table in our data vault needs its own ETL job. And there's usually a few manual steps to take the template, load the metadata into the template, and do the mapping and compile and run the job. The second approach is to try and get the data integration suite to cycle through metadata from a driving table and populate hubs, links, and satellites based off the metadata. So in these cases, we're trying to get the integration suite to generate ETL jobs or generate database code to do the loads for you. And you're looking at maintaining the metadata, the source of target mapping metadata in some driving tables. In the DIY approach, we're just using whatever software we have available to build data vault automation, usually inside the database. But I've seen accelerators used where it's built, the mapping is built in Excel. The data vault decisions are made in Excel, and it generates stored procedures or code out the back end. I've seen automation frameworks completely built in database code. And I've seen modeling tools used to build data vaults, and then the deploying those into the database and then writing the code to populate that model. There are also some open source options out there, code that you can use to help automate your data vault, like dbt vault. So these are the 4 categories of tools that I've seen used for data vault automation, in the order, I think, of easiest to hardest in terms of getting started with these tools. What I've done here is looked at the 3 main types of functionality we're looking for from data warehousing tools, and I've mapped each of the tools on the market to their capabilities across these 3 capabilities. So on the top left, we're looking for tools that can populate and automate data vaults, hubs, links, satellites, pits, and bridges. And in this particular segment, I can see the build for data vault tools, Vault Speed and Data Vault Builder, and also the data vault automation tools, Bimmelflex, Warescape, Irwin Edge. These are overlapping into the data integration area. In data integration, we see the data integration suites like Talend, IBM Information Server, Informatica, SAP, And they're overlapping with the data governance software because these tools tend to come with business glossaries, data catalogs, data quality scorecarding, data profiling. So these are the tools that you use for very strong data governance and very strong data integration. These are the tools you use on the left if you're just doing data vault automation and that's your goal. The very bottom of those tools that tend to be just good at data integration, like Oracle Data Integrator or SQL Server integration services, they're not strong on data governance tools, and they tend to not have any out-of-the-box data vault automation, but they can be coded and configured to support that using the ETL or ELT DIY approach. And at the bottom left here, I've got those tools that aren't a suite that you would typically associate with data warehousing, but where you're just simply coding it either with a database language or some of the open source code out there from Join or dbt Vault, or a database modeling tool like SQL DBM. So you're not using any large footprint of software, you're just cobbling something together with the tools and the software you have available. What are we looking for from a data vault automation tool? So I've broken down all the functions that I think you'd need for data vault automation. And I've broken them up as to being those functions that are manual steps, part of the data vault design process, automation steps, things that can be automated easily by data vault automation tools, and advanced automation, things that are a bit harder to code that you might want on a more mature data vault. And I've just marked the things that I think are tricky coding, tricky to do in a DIY approach, or tricky to do if you're trying to build your own automation tool or get your data integration suite to do automation. During the design approach, we start with hub tables. We import the metadata from source, so we need a metadata importer. And with that imported metadata, we identify business keys and we work out if they're a new hub or sharing a hub with another table or a stub hub. We then mark up those business keys. We rename, we give a name, usually a logical, friendly logical name to our hub tables and a nice logical name for our business keys. And then we are ready to generate that hub table. The data vault automation tool takes over from here. It generates the hub table, generates the mapping from landing into that hub table, and it generates the code to execute that mapping. So data vault automation for hubs involves giving us a nice user interface to make hub design decisions and then doing all the rest as generated code. Once I've completed these steps, I would expect to be able to run the DDL script to create the table, and I would be able to run the code, whether it's a stored procedure or an ETL job, run the code to populate the hub table. With satellites, we have a similar design step. We're importing metadata from source. This time we're identifying the key fields, but then we're marking down all the other fields of the satellite, and we're deciding whether the table needs to be split into multiple satellites. If you have a lot of columns and the data isn't very well normalized, then you may want to split the data up under data vault rules into multiple satellites. You also mark CDC versus non-CDC fields. By CDC, I mean change data capture. We may have fields within the source data like a creation date or modified date. We might want to exclude them from the normal CDC done by data vault satellites. We can also mark effectivity satellites. We can mark effective start and end dates. And we can also decide if this satellite needs to be tracked for deletes. In a normal data vault satellite, you insert new records and you insert a row for updated records. You don't insert a row for deletes. You can't track deletes through a normal satellite. In data vault modeling rules, the deletion of records at source go into a status tracking satellite. So let's step through the next steps. So after we've decided how we're going to organize our satellites, what their business keys are, and how we're doing the change capture on them, we have a process that we call hard rules. Hard rules are those rules that we run against data on the way into Data Vault that don't reinterpret or transform the data too much. Hard rules can typically be things like changing the data type to standard data types, rename a column, trimming a column, changing from a text date to a native database date field. The thing about hard rules, they're usually quite easy to write, but they're very repetitive. They happen to be present in most of our data vault loads for satellites, and we want to reproduce the same hard rules whenever we see a column of the same data type. We want to automatically apply that same hard rule. So a good data vault automation tool has a editor for entering hard rules as a one-time task, and then an engine that applies those hard rules to all the satellites it sees where they match the same attribute to that hard rule, in that the source data type and the target data type hit a certain pattern, the hard rule will be applied. So every time we see a string date in a certain format, there's a hard rule to turn it into a database date. Whenever we see a field that is a fixed width text, there's a hard rule that will trim it, then do a front or back trim on it. So after we've defined our hard rules and they've been applied, we would want the automation tool to generate the tables and then all of the mappings from landing into those tables. This is a bit more complex because inside these mappings, we've potentially got dynamically added hard rules, and we've got the #diff function for change data capture. So we're looking at that mapping to be generated for us and for it to generate the database load code to populate the data into that satellite table. We can also have, and this is for a standard satellite, we can also have a pattern where we populate a multi-active satellite. That's a little bit more complex. It's a harder change capture code. You're tending to do change data capture on an entire set of records to see which ones are still active rather than one record at a time. So it's a more difficult pattern, but it's a similar satellite pattern. And then the final pattern is the status tracking satellite for deleted records, or the record tracking satellite for deleted business objects. We again are looking at a bespoke pattern there that can spot deletes at landing by either receiving deleted notifications on landing or comparing the table on landing to the satellite to see what's been removed. We then populate that into a status tracking satellite. So 3 main patterns of satellites, and all of this side fully generated code. With link tables, we are looking at spotting the foreign keys within the landing tables and turning them into link tables. We're looking at a relationship of keys and identifying the driving key and marking that up as the driving key. Usually it's the first foreign key that you put into a link table is the driving key. We then may have link tables which require a dependent child, and this can be hard to code in a fully automated framework. But essentially, if you have something like an invoice number in your primary key of your link table, it's not linking to a hub because invoice line item number is not linking to a hub because invoice line item numbers number from 1, 2, 3 to upwards, they're not meaningful business keys, so they don't get their own hub. So for dependent child functionality, we're looking at a data vault automation tool that can let you flag columns on landing that should be dependent children in a link, and having potentially 1 to n children and generating the link code from that. So there's 2 complex things to code into your automation framework. That link tables can have many business keys and can link many hubs, 1 to n number of hubs. So you need to be able to dynamically add extra columns into your link, and it can have 1 to n number of children. Usually there's 1 dependent child, but you can have multiple dependent children. There's also a link pattern called non-historized link or transactional link. This is where you don't require a link in a satellite. You can roll all the satellite fields up into the link because it's a transaction satellite. The data within that satellite, within that link, never changes, so it can be stored directly on the link table as an insert-only transactional link table. Out of these 3 patterns, we're looking to generate link tables and the mapping from landing into those link tables and the load code from that. So generating a normal link load job, or generating a link load job with a dependent child key, or generating a non-historized link. So 3 patterns there that we would like to automate with our Data Vault framework. They're the main parts of Data Vault: hubs, links, and satellites. let's look at some of the additional components on top of that raw vault. We would like the automation tool to also generate our database indexes for us. Data modeling tools are usually quite good at this, but we're looking at primary keys on hash keys in each of these tables, and in the load date field on each of these tables, they represent the primary key of tables, and of course, indexing for foreign key relationships. We're also looking at some query optimization tables, the point in time tables, and the bridge tables. I'm not going to go into the functionality of those today because you can look that up, but most data vault automation pure play tools handle these now quite well. And they're very important if you want a relational data vault that's easy to query and has fast query time. Finally, we have the database views that sit over the top of the raw vault and its pits and bridges. We can have a current view. What does our data currently look like today on raw vault, ignoring superseded rows within the data vault, or the historic views on vault? How do we see what the data looked like at the same time last year, or at the end of last month, or at the end of last year? So these two views are fairly common. The current view is used for looking at what data looks like today and doing change capture or pulling it into type 1 dimensions. And the historic view is very useful for creating type 2 slowly changing dimensions to rebuild what the data looked like at various points in time, and then to load the fact tables against the snapshot of what those dimensions looked like against the right dimension rows. And we also have, in some cases, we need to build a historic data load framework so that we can potentially go back in time and reload previous snapshots of data from an archive or from history tables within our source systems, where we have a requirement for a historic timeline of data to be in our data vault from day one. And typically I get this requirement where it's very important for the business to compare the upcoming year to the previous year. So they'll want to load in end of month snapshots from the last year, from each month of last year, so they can compare it to this year. So there's usually some special automation about rebuilding that history and retrospectively populating an applied date within those tables and rebuilding the timeline of that data. And that's usually fairly tricky to do. So they'll put that as a separate tricky coding component. So there are all the components of data vault automation. You can see there's a lot of pieces to build. The pure play data vault automation tools have user interfaces for all of the steps on the left and generators for all of the steps on the right. The data warehouse automation tools, they have their own special user interfaces on the left that are, from a data vault automation perspective, most of these functions have been grafted into those automation steps as special property tables or properties. And they do all the automation on the right. They're very good at generating all of the code and all of the tables on the right. When you have a data integration stack, the DIY data integration option, you tend not to have anything on the left. You don't have nice user interfaces for making these decisions. You tend to have to use a data modeling tool to help with the models, and you have to use the ETL mapping functions to help with the mappings. So you end up doing a lot of the left stuff tends to be in various tools, and that tends to make it hard to automate the right-hand side. So you end up doing more steps, manual steps on the right. You tend to have to do manual steps for hard rules and for creating mapping specifications and coming up with the code on the right.
Wow, I hope you enjoyed that. Vincent's such a great speaker and has great insights into the current state of Data Vault and also, obviously, the innovation in automation tools that's happened over the last few years. So if you enjoyed what you saw today, then please hit the like button, subscribe, and obviously click so that you get those notifications. And also head over to the Data Vault Innovators site, www.datavaultinnovators.io. Select yes for notifications, and you'll get all the updates of all the new content that comes along there. Thanks for joining us today.